Hello, and probably for the last time, so not too much more for us to do. And parting is such sweet sorrow, I guess. In this question, there's a lot of reading, there's a lot of words, and we just need to sift through it and find out the actual math. So if we look at this table of values, tells us at any given hour, from 0 to 12, how the rate at which water is being pumped into this swimming pool. So this table of values tells us how the rate at which we're pumping water into the swimming pool. Water is also leaking out of the swimming pool. It's leaking out of the swimming pool according to this function R of t. So that's the rate at which water is leaking out. We were also given that at the initial condition, at time 0, the pool contained 1,000 cubic feet. So I'm just going to kind of make a note of that initially there was 1,000 cubic feet in there. So for part A, now that I know what all my variables represent, I can jump into kind of answering these 4 questions here. Using a midpoint Riemann sum with 3 subintervals of equal length, we want to approximate how much water was pumped into the pool. So we want to accumulate the rate at which water was pumped into the swimming pool, and we want to do this using 3 equal subintervals. So from 0 to 4, 4 to 8, and 8 to 12. So each of those subintervals has a base of 4. The first subinterval, from 0 to 4, will have a height, if we're using a midpoint approximation, of 46, plus the second subinterval will have a height of 57, and our third subinterval will have a height of 62. Do out that arithmetic, and we get 660 cubic feet of water was added to that swimming pool over the course of those 12 hours. For part B, we want to calculate the total amount of water that leaked out of that swimming pool in those 12 hours. We have the rate at which the water leaks out, so we want to take the definite integral to accumulate that rate from 0 to 12 of R of t dt. And this is one where, since it's a calculator active question, we can go to Math 9, plug in our lower limit, our upper limit, type in that function, and we get 225.594 cubic feet. Part C is asking us to use these results to approximate the volume of water in the pool at 12 hours. So if we think about the volume will be equal to that initial condition plus how much did we add minus how much did we subtract. So how much did we pump in, how much leaked out. Initially, there was 1,000 cubic feet of water. We added 660, and 225.594 had leaked out. Now if I do this out, I get 1,434.406 feet cubed. It asks us to approximate this to the nearest cubic foot. So since 0.4 is less than a half, I guess we can round this to 1,434 cubic feet. I should probably label this correctly as part C. All right. Lastly, part D is a 2-part question. The first part of part D says to find the rate at which the volume is increasing at a time of 8 hours. So if I think about what that change in volume is, the change in volume will be equal to how much did we add minus how much leaked out. And if we want to evaluate this at a time of 8, how much was being pumped in at a time of 8? At a time of 8, if we go back to the table of values, 60 cubic feet of water was being pumped in. So P of 8 is equal to 60 minus how much leaked out at 8? You need to be red. Well, to find R of 8, we're going to plug in 8 for t into that function. So R is defined to be 25 times e to the negative 0.05 times 8. And this is equal to 16.758. So do that subtraction, 43.242 cubic feet per hour. This is cubic feet. So that's our change in the volume at a time of 8. The second part of D wants us to find the change in the height, or how fast is the height of the water increasing at a time of 8. So we know that the volume of a cylinder is equal to pi r squared times h. And it looks like we have 3 variables here, but since it's a cylinder, the radius is constant. The radius of this cylinder was always 12. So if the radius of this cylinder is always going to be 12, if we plug in 12 for r, volume is equal to pi times 12 squared, which is 144, pi times h. So now to find the change in height with respect to time, let's take the derivative of both sides. So the derivative of the left side, dv dt, is equal to, the derivative of the right side will be 144 pi dh dt. We're looking for dh dt, and in the first part of D, we found the change in volume at 8. So we can plug in that 43.242 is equal to 144 pi dh dt. So to find dh dt, let's divide both sides by 144 pi. And here's just a little calculator note. So when I do this in my calculator, 43.242 divided by, I want to put parentheses around this, 144 pi, because I'm dividing by that quantity. I don't want to just write this. I don't want to write this, 43.242 divided by 144 pi, because it's going to take 43.242, divide it by 144, and then multiply by pi, which isn't what we want. We want to divide by that quantity, 144 pi. And when we do this out, dh dt is equal to 0.095, and then the height will be increasing in feet per hour. Okay, so that's it for us as far as the AP exam is concerned. So let's make sure that we know those 7 free response questions. We know as many of those multiple choice questions that we have as practice. And if you have any questions, please let me know. And it's truly been awesome.